Welcome along to this video. This is where I'm just going to show you something rather freaky that I discovered whilst I was building this KT88 tube amp that I'm working on at the moment. So this is a brand new design, and this is the first prototype of it. And when I was testing the driver board, I discovered something a little bit interesting. So at the moment, the driver board, the circuit diagram for it's up on the screen at the moment. So the driver board should present a signal to G1, the control grid of the KT88. And so what I'm doing here, just to test it since it's a brand new board, is I'm putting in a signal into the input, and I want to see a signal, the corresponding signal with some gain on the output at the G1 of the KT88. So the oscilloscope is looking at G1 of KT88, and I'm going to power it on at the moment. And our voltages should start to come up, our voltage rail should start to come up, and on the oscilloscope screen we should start to see the signal appearing at the KT88 grid. And sure enough we do. So I'm putting in a 1 kHz sine wave at 230 millivolts peak to peak, and I'm getting around about 200 volts peak to peak of clean sine wave signal at the G1, which is about what I'd expect. Now the KT88s aren't connected up at the moment, so the only thing that is connected is the cathode is connected to ground through the 10 ohm current measuring shunt resistor. Nothing else, right? And the filaments, or the heaters, are not connected at the moment. But now, I'm going to put this connector on, which turns the filaments on, and watch the oscilloscope screen. As the cathode heats up on the KT88 output tube, it's going to start doing this. So what's happening there is the tube is starting to act like a diode, effectively, and the control grid is acting a little bit like an anode, and the signal is of sufficient voltage that it is actually clamping that and conducting current down through to ground. So if we put up a cursor here, we can see that it's around about 17 volts or 16 volts or so that it is putting there, which means that it's anything more than 16 volts is conducting down through to ground, through the cathode. And if I remove the filament from the tube and wait quite a long time,
a few moments later,
you can start to see as the cathode cools, then the signal starts to return to something appearing more normal. Obviously this won't be a problem when the amplifier is in operation, because there'll be a negative bias voltage on that grid to stop this from happening. I thought I'd share this because this phenomenon had me scratching my head for a while, because the first time I tested this board I had the filaments plugged in to the output tubes, and I was wondering what the heck was going on. And it was only in the shower that I had the thought that the output tube itself might be acting as a kind of primitive kind of Zener diode, allowing only a certain amount of voltage through before it started to conduct. And it turned out that's exactly what it was.